Alright everyone, this is your introduction to inverse trig functions, which is really going to be all about knowing your unit circle and using it in new ways. So first of all, for an inverse function to exist, the original function has to be what we call one-to-one, meaning there's exactly one y value for every x value and the other way around. We can kind of see this using a graph with the horizontal line test. So if you remember the vertical line test that shows whether something is a function, a horizontal line test shows me if the function is one-to-one. Basically, a horizontal line cannot touch the graph in more than one place at a time. The domain of an original function is the range of its inverse, which is information that we're going to need to use. And the other thing is true, or the opposite of that is true as well. The range of the original function becomes the domain of the inverse. Now, if you need more time to write, you can pause the video here. So let's consider one of the trig functions we know. Sine and cosine are very similar, so we'll consider sine. The question is whether this function is one-to-one. Hopefully, if you just take a horizontal line, you can see the answer is no, because I hit more than one point with my horizontal line almost everywhere. Now this is a problem because I need to be able to use inverse sine, which I can't do unless the function is one-to-one. So the way we deal with this is we restrict the domain. And it turns out, you can kind of verify this using your unit circle, if I restrict the domain to negative pi over 2 to pi over 2, now I know there's no negative angles on your unit circle, but negative pi over 2 matches up with 3 pi over 2, then my function becomes one-to-one. Between these two angles, every y value only matches to one x value. So, first of all, you're going to see a little bit of notation. You've seen this before. The negative 1 power means inverse. You might also see arc sine or arc cosine or really any of the 6 trig functions we've talked about. Both of these are asking you sine of what angle is x. So your answers for all of these questions are going to be angle measures. Now just to kind of show you graphically, if you're a visual kind of person, here's the graph of the arc sine function. Notice my restricted domain for sine was negative pi over 2 to pi over 2, so that is now my range for arc sine. And my range for sine, it bounces back and forth in that wave from negative 1 to 1. That's the domain of arc sine. It's basically just a sine function that's been flipped on its side. This is true of all the inverse trig function graphs. Now here's the thing you really need to know and take some time to memorize. Each of the 6 trig functions has its own restricted domain, but there's only really 2 options. Sine, tangent, and cosecant, sine's reciprocal, all have a restricted domain of negative pi over 2 to pi over 2. So your answers can only be between negative pi over 2 and pi over 2. The same sort of idea happens for cosine, secant, the reciprocal of cosine, and cotangent. They all have a restricted domain of 0 to pi. So your answers have to be between 0 and pi. Now again, if you need more time to write this down, you should pause the video here. This is really important. This is something that you're going to need to memorize. So let's do some examples. It's kind of hard to see what I'm talking about without some examples. So my first question is to find arc sine of negative 1. So what that means is where on the unit circle, we're talking about an angle, is sine negative 1. So if you're thinking about your unit circle, the only place that happens is 3 pi over 2. Now here's the problem. That's not in my restricted domain. So remember for sine, the restricted domain is negative pi over 2 to pi over 2. So I need to find the equivalent of this angle that's in that domain. You can subtract 2 pi to find a coterminal angle, or you can just sort of visualize it. The equivalent angle to this would be negative pi over 2, which is the only correct answer. 3 pi over 2 is not in the domain, so you cannot give me that for the answer to arc sine of negative 1. Sine inverse of 1/2 works kind of the same way. Where on the unit circle is sine 1/2? You can kind of think of using your hand trick. So if you're taking your left hand, I want sine to be 1/2, so I want one finger left below my turned down finger, which means I'm looking at those pi over 6 angles. Now the places that that's positive would be 1 pi over 6 and 5 pi over 6, which is in quadrant 2. But remember my restricted domain, negative pi over 2 to pi over 2. The only one of those angles that's within that domain is pi over 6. So even though sine is also 1/2 at 5 pi over 6, it is not in my domain. Now this last one's kind of weird because sine is not square root of 3 anywhere on the unit circle. Now these are really going to be no calculator problems. You could sort of use your calculator to verify. I notice we're always in radians here. But remember that the range of a sine function is -1 to 1, which makes that the domain of inverse sine. Now here's your problem. You're trying to plug in square root of 3, which is about 1.7. That's greater than 1, which means this is outside the domain of my inverse sine function. There is no such angle where this happens. This has no solution. So anytime it's outside of the range of the original function, you can say that it has no solution. Alright, so that's all been sine. We're just going to do a few more examples so you can kind of see, and if you feel like you've got it, pause the video here and try this yourself before you look at my solutions. So arc cosine of square root of 3 over 2, I'm thinking where on the unit circle is cosine square root of 3 over 2? Well, I want 3 fingers above my turn down finger. If you don't have this memorized, use this trick. That's again kind of the pi over 6 angles. Cosine is positive in quadrant 1, which would be 1 pi over 6, and in quadrant 4, which would be 11 pi over 6. Now remember that the domain for cosine, the restricted domain for cosine, is from 0 to pi. The only one of these that's between 0 and pi is pi over 6. So even though cosine is square root of 3 over 2 at 11 pi over 6, it's not within my domain. I have only one answer to all of these problems. The same kind of idea is true for inverse cosine of -1/2. So I'm thinking, okay, cosine 1/2, I need one finger above. That's your pi over 3 angles. Cosine is negative in quadrant 2, which would be 2 pi over 3, and in quadrant 3, which would be 5 pi over 3. But again, my restricted domain is from 0 to pi. 5 pi over 3 is too big. 2 pi over 3 is the only one that works. Sine and cosine are fairly easy because you can use the hand trick like that. But what about tangent? It's not a whole lot harder, but you may have to do a little bit of scratch work. So let's think. Arctangent of 1 means where on the unit circle is tangent 1? Well, tangent, if you remember, is y divided by x, or sine divided by cosine. I'm going to get 1 when y and x are the same number. Now the only points on the unit circle where y and x are the same number are those square root of 2 over 2 points, which happen at all of your multiples of pi over 4. Tangent's going to be positive in quadrant 1, which is 1 pi over 4, and in quadrant 3, which is 5 pi over 4. Now the restricted domain for tangent is the same as the one for sine, negative pi over 2 to pi over 2, which means pi over 4 is the only one that fits. Now that one's kind of easy because you can do the algebra in your head. Let's think about this one. Inverse tangent of negative square root of 3 over 3. Well, I know that I'm going to get these square roots in either the pi over 6 type points or in the pi over 3 type points. Now maybe you have memorized which ones have this tangent. If you don't, do a little bit of scratch work and figure out, okay, where is y divided by x going to give me this square root of 3 over 3? Oh, let me get the lights to turn back on. Much better. Now the place that's going to happen is at your pi over 6 angles. So I know I'm looking for pi over 6 angles. I know that tangent is negative in quadrant 2, which is 5 pi over 6, and in quadrant 4, which is 11 pi over 6. Now the trick is neither of those is in our domain, right? Neither of those is between negative pi over 2 and pi over 2. But this I could rewrite as something that is, because a coterminal angle for 11 pi over 6 is negative pi over 6. These have the same tangent value because they have the same point. So I completely ignore this, it's in the wrong spot. This I have to rework so that it fits into my domain. So your answer here would be negative pi over 6. Alright, so I have some practice for you. You have a discussion board on Canvas due by midnight. You have classwork on Canvas, which is a quizzes. You should have a link and a game code. It's kind of like a Kahoot, except you play it on your own, and then you'll get a leaderboard. The faster you answer questions quickly, the higher your score. When you're done, pick up your homework assignment. I'll give you the answers to that, and we will go over all of this again when I come back. Have a good day.